Hello and welcome back to our lesson 4.8. This is again solving exponential equations. A lot of people don't like this lesson, but realistically, I don't think it's that bad. Although then again, you know, if I don't think it's that bad, it's not exactly the easiest thing to be able to do. But hopefully, we'll see that if you just follow the set of given, set of given steps, and you operate within the sense of common understanding, it's not again, like I said, not that bad. Of course, the first thing we need to understand here, if a to the power of b equals a to the power of c, then b equals to c. That is to say, like something like if 2 to the power of x equals 2 to the power of 5, then x equals 5. This is basically how we're going to solve for x. Again, solving in the sense that we are trying to find what x is, correct? And 2 to the power of 5 is 32, and the only way that this side can be equal to 32 is if x equals 5. So hopefully we'll see that if the bases are the same and they're equal, then the exponents are also the same. So likewise, we will solve question number 1. 2 to the power of x plus 3 equals 2 to the power of 7. So of course, x plus 3 equals 7. X equals 4 minus 3 minus 3. Ta-da! That's basically it. Of course, this is not going to be the entire lesson because we're going to get into the very, very slightly more tricky situation where we have different bases. And so, of course, the idea here is that to use this formula, we need to make the bases the same. And that's what we're going to be doing here. So when you're trying to make bases the same, the easiest way to do that is to get to the lowest. Obviously, you have to kind of get to the lower base. So here we have 27, and here we have a 3. First of all, this is going to kind of bother me because this 27 is in the denominator. I want it in the numerator, right? Because I don't want anything as a fraction. So the first thing I'm going to actually do is move this 27 to the numerator. And of course, that means I'll get a negative exponent. So this is currently where I'm at right now. Again, 3 and 27 are not exactly the same base. So in order to convert them to the same base, I'm going to rewrite 27 as 3 to the power of 3. Again, I don't remember if it was in this unit that we had this big chart. Do we have that chart? Where's that chart? I think we had that chart in this unit, right? Yeah, this chart. Very important that we are okay with this chart, that we know common, exponents of these simple, or at least the first 9. This table. It's very important that you know this table, because if you know this table, your life will be so much easier when doing these kinds of questions. Like, you'll just have a much more easier time of it. Oh, there we are. So again, once you know that 27 is 3 to the power of 3, your negative 1 still stays there. I'm going to use power of a power rule, so that's just multiplying. 3 times negative 1 is negative 3. Now that I have the same base, I can say the exponents are equal. I'm going to move the 1 to this side. 2x equals negative 2. X equals to negative 1. The easiest way to check that is just to, you can just put this negative 1 into here and see if it makes sense. 2 times negative 1 minus 1 is negative 3. And I know that equals 1 over 27, because this is 1 over 3 to the power of 3, which is 1 over 27. Again, whenever you have an equation, it's always easy to check. Just do left-hand side, right-hand side check, and you should get the same answer. And yeah, that's basically it. Okay, here we have an x on both sides of the equal to sign, but that's still nothing to be concerned about. I do not have, again, I'm just going to make the base the same. That's my first step. Here I don't have the same base, 25 and 125. How do I make that the same base? again, hopefully, I'm just going to tell you now, but in terms of thinking about it, hopefully we can see that in order to make them the same, we need both of them to be a base of 5. So 25 we're going to write as 5 to the power of 2. And 125 we're going to write as 5 to the power of 3. So again, I'm going to multiply these things, power of a power rule. So 2 times 3x is 6x. 3 times x minus 2. Be very careful. This does follow the distributive property. If you want to put brackets around that right away, you should. Just because now I have to do, even if you're writing that out as an extra step, it's not necessary, but if you have to, I recommend it, because if you don't do distributive property, then of course you're not going to get the right answer. But as soon as I have the same bases, I can say the exponents are equal, and then this is just a matter of moving the 3x over to this side, so I subtract it. 3x equals negative 6, x equals negative 2. And of course, if you sub in negative 2 here, you should get 25 to the power of negative 6. And this is 125 to the power of negative 4. And yes, those are actually equal. If you put them in a calculator, or you can do that to check. Again, things like that. So again, same idea. Hopefully we see the pattern here. I have, again, I don't even have to worry about the exponents in the first, because I just see that I have different bases. I have to make the bases the same. There's multiple ways actually you can do this. And it depends on which way you're comfortable with. So for example, I would, in fact, keep the 1 over 9 the same at the first, and make this 3 into a 1 over 3 to the power of 3x, so that I just have positive exponents. Positive exponents are much nicer to deal with, I think. And it's okay that I'm a fraction, because the same kind of laws operate, right? 1 over 9 is just 1 over 3 the whole squared. X plus 2 equals 1 over 3 to the power of 3x. Combining the exponents here, using distributive property, 2 bracket x plus 2 equals 1 over 3 to the power of 3x. My base is the same, so my exponents will be the same. So 2 bracket x plus 2 equals 3x. 2x plus 4 equals 3x. Move the 2x to that side. Negative 2x, 4 equals x. X equals 4. Alternatively, of course, you can do 9 to the power of negative 1 x plus 2 equals 3 to the power of negative x. Then you would I would multiply this in, or actually you can even do like a, power of a power of a power, 3 squared times negative 1 times x plus 2 equals 3 to the power of negative 3x. Again, whichever order you want to do that in, as long as you get somewhere. So if I multiply all the exponents, negative 2 times x plus 2 equals negative 3x, because now my base is the same. And you can see that this is the same thing as here, except there's no negative signs, which of course you will remove in the next step and get the same answer. So whichever way you feel comfortable doing that is fine. Here we have the slightly more difficult cases, so of course we're going to put stars beside them for what it's worth. I'm not actually sure. I don't know if you heard, but there's news, again, depending on when you're watching this video, you probably would have heard, but there's news that schools won't open up until May 30th, at which point I don't even know if there's any point in opening them up, because you're going to come back and that's basically time for one more unit and the exams. So that's not a lot of time. So you can be fairly certain that you're going to be doing the next couple of units online as well, from home. Again, in terms of whether there will be a final exam, of course, I have absolutely no idea. But it looks, again, in terms of the hopefulness, I think it hopefully it looks like any decision made will be in favor of, like, students not going through undue stress and getting troubled studying for the entire course that they have learned online for a final exam. I doubt there will be something that severe. If there is a final exam, it will be like nominal, just to make sure you understand like the basic concepts of everything, and not like a hard like exam type deal. So that's hopefully good news there. But yeah, okay. Continuing on with our case, here we have three different bases. We have a 16, a 2, and a 4. And of course, the first step is to, of course, make those bases the same. You can't really do anything with exponents unless the bases are the same. So that's what we're going to do first. 16 is 2 to the power of 4. Still have this 2 to the power of x minus 3. This is 2 to the power of 2, 3x minus 1. This is 2 to the power of 4x times 2 to the power of x minus 3 equals 2 to the power of 2 times 3x minus 1. Just power rule. And here, of course, we have to combine the exponents in another way. Because, again, you need, like, on this, you have, like, 2 to the power of something equals 2 to the power of something. There's no, like, a times, like, b times a times c equals. There's none of this stuff. There's just one term on the left-hand side, one term on the right-hand side. One base on the left-hand side, one base on the right-hand side. That's what I'm going for. And as long as you have the same base, it's very easy to combine, because 2 to the power of this times 2 to the power of that is 2 to the power of a plus b. I'm going to use the distributive property here to get 6x minus 2. 2 to the power of 5x minus 3 equals 2 to the power of 6x minus 2. And of course I will now, because my bases are the same, my exponents are the same. I think I'm going to move the 5x over here, the 2 over here. I get negative 1 equals to positive x, so x equals negative 1 is my answer. And again, this is some kind of a weird thing that's going on. You have to be careful here, because this is very specifically 8 to the power of x squared, right? It's not 8 to the power of x to the power of 2. It's not this. So because this would just be 8 to the power of 2x. If we wanted 8 to the power of 2x, we would have given you 8 to the power of 2x. This is 8 to the power of x squared, which is slightly different than 8 to the power of x squared, right? Because x squared is not always 2x. So hopefully we see the difference there between these two things, namely, hold on a second while this erases. Yeah, there we go. 8 to the power of x squared is not the same as 8 to the power of x squared. And with this case, I'm doing my x squared first. In this case, I'm just going to break this down to 8 to the power of 2x, which is different than 8 to the power of x squared. So in terms of what I'm doing here, again, the bases need to be the same. So 8 I'm going to write as 2 cubed to the power of x squared. And 2 cubed. And now here, this is a multiplication rule, because I have a power of a power of a power. So 2 to the power of 3 times x squared equals 2 to the power of x plus 2. And of course, here I have my bases are the same, so exponents have to be the same. I know this looks different to everything that we've done so far, but whoops. Again, you just set this equal to 0. We know how to solve quadratic equations. So you'll see here that 3 is a very nice number for which I can just, oops, that was way too much erasing. So I need this to add to negative 1. So 3 times negative 1 2, I think would work. And therefore, again, solving for x means telling me that x equals negative 2 over 3 or x equals positive 1. These are my answers. So very important that you go to this last step and solve for x. I mean, given that this equals 0, that's how you solve for x, right? You take negative, again, the shortcut is just you take the negative of this, divide by that, negative of this, divide by 1, etc. So hopefully we'll see that. Very important question. Don't get confused there. But yeah, that's basically how to solve for exponents. Again, I'm too lazy to download the worksheet 4.8, but if you have any questions, of course, leave a comment at the bottom of this video or get in touch with either me or Mr. Tremoli, however you like. This is important. This is the last kind of important lesson. I'm debating whether to actually even do lesson 4.10. This is like it's kind of easy and, just what's the difference between linear, quadratic, and exponential equations, blah, blah, blah. Easy stuff. But we'll see. I mean, we'll do 4.9 first. That is a kind of important lesson that there will definitely be a question on the assessment using applications, because that's generally where exponential functions are most useful, like in terms of their applications. So we will talk about that in the next lesson. Until then, peace out.